Hi guys, welcome back to the old boys bench. We have the motor apart. Took a little bit of doing. These ones are actually riveted together, not bolted, so you have to drill the heads off the rivets and remove them that way. We have 4 bolts of course to put the motor back together. We have our rotor and of course our 2 brushes in there. You'll see here that the way this is wound, the fields are about 80 degrees around the rotor, each field. There will be 2 of them that light up each time. We have removed all the unnecessary junk, as in the sensors and everything. We're left with 3 wires. This one here, as you can see, is the centre tap for the armature windings, and of course our 2 ends. Not quite centre. I've got about 1 ohm on one side and about 1.3 on the other, but close enough for what we're going to be doing. These are going to be our generator coils. Unlike most, they are not going to create a lens force effect and bog the motor down. They're actually going to speed the motor up and reduce the current draw within the motor, providing we wire it up correctly. So each time one of these, or 2 of these poles fire up, which are of course 180 degrees out, they're only going to be attracted to the steel core of the coils, as we'll be no longer using the electromagnetic effect of our field windings. So that's basically it. We're just going to put it back together. We're going to test it on DC and we're going to test it on AC. And we're going to see the importance of hooking it up correctly, as in to which way you take the power from the coils. One way will bog the motor down, the other way will speed the motor up and reduce our current draw. There has been some talk of transformers being saturated, and adding a load can seem like it's reducing the input of the transformer. This will not be the case. Very low voltage, very low current. About 1.2 ohms on each set of windings on this, so it is a different effect than that. So we'll go ahead and put the motor back together and do some testing.